So now we are moving on from ratios to solving proportions. And we know that proportions are two equal ratios or two equal fractions. And we know that proportions are solved by good old-fashioned cross-multiplying. But here's the thing. We kind of did the easy cross-multiply problems yesterday. And so now we're going to move on to what I call chunky cross-multiplying problems. It's still that same quote-unquote butterfly method, but now 2 times the quantity x plus 1 is equal to 12. So you got to distribute the 2. Rocco, you could say, oh, hang on. And then x equals 5. The next one, same thing. 3 times the quantity x plus 2 equals 5 times 6, which is 30. Now, because this is not always going to work, but I'll just show this to you. This is a little interesting way to do it. You could divide both sides by 3 instead of distributing. That only works when they're both divisible by 3. But in this case, they were, and then I subtracted 2 from both sides and got 8. Just a little bit of a shortcut, so to speak. It's not going to work here. 3 times the quantity x plus 1 equals 2 times the quantity x plus 8. So 3x plus 3 equals 2x plus 16. And you should be good enough at solving that you could even do things in your head, like subtract 2x in your head, right? Minus 2x. So x plus 3 equals 16. So subtract 3 from both sides, x is 13. You could even distribute as you go. So I could just say, okay, I know I'm going to distribute the 3 and just write 3x plus 6. I know I'm going to distribute the 5, and write 5x minus 15. Subtract 3x from both sides. Here I get 2. Here add 15 to both sides, 21. So 21 over 2, or 10.5. So a little bit harder, or what I call chunky cross-multiply problems. Now we're going to do a little segment addition, which we did back in the beginning of the year. The ratio of AB to BC is 3 to 1, so that means one chunk is 3x and the other one is 1x. Kind of reminds me of those 2x and x problems that we did back in chapter 4. Your equation would be the two little sides add up to, or two little segments add up to the big segment, or 4x equals 28, so x is 7. And then you would go back and plug that back in. So 3 times 7 there is 21, and 1 times 7, of course, is 7. You're going to see that same question quite a bit. These are little proportions, like little proportional story problems. A car can travel 236 miles on 8 gallons of gas. How far can it travel on 10 gallons of gas? Notice that I'm keeping my units in there so I can see miles in the top and gallons in the bottom. So 8x equals, it's going to be 2360. And if I divide both sides by 8, yikes, I don't have a calculator. 2360 divided by 8. It can be done, folks. So this would go in twice, 16, 76, would go in 9 times, 72, and that would be left with 40, so 295. So 295 miles. And we would want to have the units on there. So, yeah, that kind of finishes the algebra type of thing that we would need to do our problems. Now we're going to get back into what we're really learning, which is similar shapes. We've talked a little bit about similar shapes, that the corresponding angles are congruent and the corresponding sides are proportional. And we have a symbol for similar, which is just a squiggle. Symbol for similar, which is just a squiggle. Two polygons are similar. Now, sometimes we don't even need a picture. We can just look at the order of the letters. You'll remember this from earlier chapters. Angle N goes with angle R. Angle P goes with angle S. Angle Q goes with angle T. If I say PQ, it's going to be proportional to ST. NQ to RT, and then PN would go with SR. Notice here I have congruent symbols because the angles are congruent, where here we just have arrows. We're just saying that they go together. They're actually proportional. So we would fill in this like NP over RS equals PQ over ST equals NQ over RT. And that'll make more sense later, but that's our statement of proportionality. Here we look at the pictures and we notice, okay, F is the right angle, right? That goes with D. G has one hash mark, that goes with B. And then E has a double hash mark, so that goes with C. So the congruent angles are angle G with angle B, angle F with angle D, and angle E with angle C. And we could do our proportionality statement. BD goes with GF. DC goes with FE, and BC goes with GE. And I'm just really looking at that statement there, the order of the letters to help me with that. The final thing is scale factor. And we've done scale factor a bit before when we did dilations. Scale factor is the reduced ratio of the corresponding sides. So colors are super helpful for this. So we look at these sides that correspond, like 8 goes with 24, and we're going to write that as a ratio. 6 here goes with 18. And then on the bottom, 4 goes with 12. All three of those fractions reduce to the fraction 1/3. That is our scale factor, the reduced fraction of the corresponding sides. So if we look at the triangles down here, this is the same triangle. This is just little different numbers. LMN is going to be similar, see the squiggle? LMN is similar to YZX. YZX. So the proportions would be like this, 8 over 12, oops, 8 over 12, those two go together. It's not letting me write it. There we go, 8 over 12 equals 6 over 9. We always do it as we read. The first one in the numerator, second one in the denominator, equals 4 over 6. So it's numerator, denominator, numerator, denominator, numerator, denominator. All these three fractions reduce to, you're right, 2/3. That is the scale factor. Let's look at another one. If I say JKL, I have to say EFG. That's how they match up, right? JKL matches up with EFG. Then it helps if you do colors, like 9 goes with 4.5. I know that's a decimal, but we're still going to write it. 9 over 4.5 equals 15 goes with 7.5. And then finally the 12 goes with, you're right, 6. We're going to make those three fractions and then say, what do those three fractions all reduce to? 2 over 1. And that's our scale factor. People will say, could I say 2? You could. 2 over 1 or 2. Last one. Now this one's a little tricky because it's kind of upside down, right? A, B, C, D. Let's see, which one goes with A? I feel like the A goes with E, don't you? E, F, G, H, yeah. So this means this side of 6 here is going to correspond to this side of 9. So the 6 over 9, and that's going to go for both of those. Those match, the 6 and 9 and the 6 and 9. And then if we look at like the shorter segment here, the 4 is going to go with 6. And then the 8 is going to go with 12. And what do all those reduce to?
2 over 3.
2 over 3. So they all reduce to 2/3, and that's the scale factor. We're going to spend a lot more time on scale factor in this chapter, so this is just an introduction to similar triangles, to scale factor, and also a review of some harder cross multiplying.